Hi, everybody. Thank you for joining today. We're going to get started in about 45 seconds to a minute to allow any last-minute attendees to join. Okay, I think we're good to go. So thank you again, everybody, for joining. My name is Erica Groche. I am a public affairs officer with NOAA's National Weather Service, and that includes the Space Weather Prediction Center, or SWPC. This webinar is going to provide information about the upcoming geomagnetic storm that's expected after a strong X-class solar flare left the sun at about 10 p.m. yesterday evening Eastern Time. This call is for the working news media, and it is being recorded. If you do not want to be recorded, please leave the webinar now. The recording of this webinar will be available on SWPC's website later today. If you're not a member of the press, you're welcome to listen, but please don't attempt to ask any questions at this time. We need to reserve this time so that reporters can ask their questions. For those of you who would like to ask a question, please note that on the panel to your right, it usually pops up on the right on the GoToWebinar window, you'll see the button that says questions. Click that arrow and you'll be able to enter a question into that box. If you would like to ask a question verbally, you can hit the little hand icon and raise your hand, and I can call on you manually that way as well. Okay, so today we have with us Sean Dahl, the service coordinator for the Space Weather Prediction Center, Rob Steenberg, space scientist for SWPC, and Brian Brasher and Mike Betwee are also joining us from the Space Weather Prediction Center. In the other window, you see Clinton Wallace, who's the director of the Space Weather Prediction Center, all joining us today. All right, without further ado, I'd like to turn it over to Sean.
Yeah, hello, everyone. Welcome to this webinar to talk about the upcoming severe geomagnetic storm forecast. So as mentioned, I'm Sean, the service coordinator here at the Space Weather Prediction Center and part of the forecast staff. So as you all know by now, we are forecasting a severe, a G4 geomagnetic storm. The current anticipation is that is going to arrive tomorrow morning to midday Eastern time and perhaps continue on into the following day. So our intent here today is to go through and show you a few slides and discuss what took place, what we're expecting next, and then when we'll actually know what the CME, this coronal mass ejection, I'll describe that more in a minute, could anticipate what it might look like when it arrives here. Brian, please, next. So first of all, we're in solar cycle number 25. These are an average 11-year cycle. It could deviate from that and be longer or shorter, but we are in the midst of solar maximum right now. We just don't know if we've reached the peak yet. That'll be decided later and could be either sometime this year or even early next year. Bottom line is we're still in for a ride with this solar cycle activity through this year, well into next year, and even into early 2026. The sunspot groups that you see on this animation on the top right of the screen are the current sunspot groups of concern. This is the current state of the sun. It's the region up north, that sunspot group in the top half of the sun, that erupted with the X1 flare, the R3 level event yesterday, that immediately gave signs that we had a strong release of solar material and embedded magnetic fields headed towards Earth. That is what we call a coronal mass ejection, or CME for short. So we rapidly started analyzing imagery when it came in. We'll discuss that in a minute. You can see the solar cycle has been quite active. The plots on the bottom represent the original forecast for the solar cycle done about 5 or more years ago, and that's the lighter shade of color you see. That forecast had to be modified because this solar cycle has been quite active. So it was readjusted, and those are the darker colors you see above it now. And you can see the line plot shows kind of the current state that's measured basically of the overall average every month. And that's even approaching the outside of the margin of error of the adjusted cycle. Next slide, please. So yesterday, this is the X1 flare, the R3 level event that happened. The concerning thing here is it was right in the center of the sun. This region happened to be rotated right into that position, was complex enough, and erupted with this strong, long duration flare. That did disrupt any HF, high frequency communication bands for people on the sunlit side of our planet. We were not on the sunlit side of the planet during that flare because that was in the evening across most of the country. So that is the flare that was of concern. Next slide, Brian. Now it's the coronal mass ejection. You can see that this image is animation is awfully fast here, but you can see the CME evolving out round spherically from the sun. That's an indicator that it has a very Earth-directed component. The funny looking thing to the right, if you don't know by now, that is a comet that is rounding the sun as we speak. It has nothing to do with the activity that's currently taking place or a concern. It's just an artifact that's in the imagery that we can't do anything about. That CME is traveling towards Earth at over 2.5 million miles per hour. And we anticipate that arrival timing to be, as I said, tomorrow morning to midday Eastern time. These CMEs, we do not know what their full structure is like until they arrive closer to Earth. Next slide, Brian. So this is one of the tools, one of the models that we use here at the Space Weather Prediction Center to help us determine arrival time and whether or not they're directed towards Earth. We run multiple models of this CME and any other CMEs that we have concern with. This is the run we decided to go with and base our forecast timing off of. What you're seeing in this kaleidoscope of colors is really the solar wind emanating from the sun, and that is the high-speed CME. You can clearly see this propagation of material going from the middle of that plot, which is the sun, to the right side, which is Earth right in the middle, that little green dot, if you can make that out. That is the CME at hand. You can see it has a very Earth-directed component. It will wash over Earth as it arrives here and will be in the magnetic field of that CME for a good number of hours, potentially even a day. But this is a very speedy CME. It's the fastest CME that we've really measured that had a total Earth-directed component in the solar cycle thus far. Next slide, please, Brian. So we have the G4 watch out. We issued that this morning because of the CME potential. We were confident enough at this point. So we have a high level of confidence in a CME arrival at Earth. We have a fair amount of confidence in our timing. And intensity, however, is always a question at hand. What we have with this G4 watch is really our best guess potential because we have no understanding of what this CME is actually like. We won't know that until it arrives at a satellite 1 million miles from Earth that we use to measure these changes in the solar wind. Next slide, please, Brian. That satellite, there's two of them out there. One is called ACE, the other is Discover. Discover is a NOAA asset. And this is what we utilize to measure the solar wind. The plot you see on the right is the real-time solar wind plot that is available on the web page, always updated in real time, so anybody on this call can monitor that and see for themselves when the CME has arrived. What we'll be looking for is changes in the magnetic field and the speed of the solar wind in particular. That's when we get an understanding of just how favorable or unfavorable this CME will be for a severe geomagnetic storm here at Earth. We know the potential is there, but we can't do a warning until we see the CME arrive at that spacecraft because it could be favorably connected with Earth when it arrives or unfavorably. By that, I mean these CMEs and their magnetic component, if you think of two magnets and they have the same polarity and you try to put them together, they repel. If they're opposite, they connect and the magnets will stay together. Same thing here. If that magnetic field in the CME is the same as Earth's, we'll have an initial impact and effect, an immediate enhancement in geomagnetic response, no doubt, but we probably will not reach to those severe levels or potentially higher. If it's favorably connected as it comes through or changes into that configuration throughout its passage, then we will escalate in responses, and that's where the true potential will come in and we can issue our warnings and subsequent alerts as we reach those levels of activity. The plot on the bottom left here is the geomagnetic storm back in May. That was quite substantial, as you all know. We had 24-hour period of G4 and G5 levels, 36 hours that included G3. We were favorably connected through the entire passage of that CME. we don't know what to anticipate with this one as of yet. Next slide, Brian. I think that might be the last one. Okay, so with that said, here's what we know right now is the CME is inbound towards Earth. That's why we have the G4 watch issued. We will issue the warning when we see it arrive at the spacecraft 1 million miles from Earth. At that point, it'll be 15 to 30 minutes away based off the speed estimates we have right now. And then we will alert every time we reach one of these G-scale levels. So those will come across. That happens every 3 hours, by the way. It does, again, just the way these things are measured. Actions we've already taken here at SWPC. When I say SWPC, I'm saying the Space Weather Prediction Center, or SWPC for short. We've already been talking with high leadership. We've already been engaged with FEMA, the Emergency Response Branch of our government, of course, even the North American Power Grid. Last storm in May, when we reached G5 levels or had that potential, we talked to the power grid early, about 6 hours before the storm arrived. This time, with all the hurricane relief efforts going on and the inbound hurricane going into Florida and across the peninsula, we thought it prudent to immediately contact them now. So we did that. We've already made a call to the North American Power Grid for their understanding of to do any additional things they may need to do in preparation for the storm should we reach G4 and G5 levels, especially with the hurricane efforts and perhaps a stress grid in some areas. We don't know the true status there, but that's just our concern. They appreciated that call. They were highly thankful, and I guarantee they're already taking precautions and measures to prepare for the storm should it materialize as we anticipate. I think that is the introduction part that I wanted to go over. And since this is your time for questions, we're happy to start to entertain those at this point in time. Thank you.
All right, thank you so much, Sean. And once again, that was Sean Dahl, the service coordinator for the Space Weather Prediction Center. So we've got some questions here in the queue. I'm going to start with Brandon Vigliaro because he got his, or Vigliarolo, because he got his questions in the chat right off the bat. I'm not sure if you already addressed this, Sean. When will the storm reach L1? He wants to know, actually, when will the storm reach 1 million miles from Earth so that we can get more details on it? Is L1 exactly at 1 million miles?
Yes, that's pretty much the location of that area. Hey, Brandon, thanks for the question. Yes, that's when we'll know is when it arrives at that spacecraft. So that's the timing that we actually have here is anticipating morning, kind of the, after 6 a.m. period time frame Eastern time to midday Eastern time. That's when we anticipate it to arrive at L1. And within 15 to 30 minutes from that point, it should arrive at Earth.
Okay, thank you. A question from Lucas Combos. Assuming the strength is as expected, how far south might the aurora potential be in the continental U.S.?
Hey, Lucas, thanks for the question. We never know for sure with the auroral development of how far it will go. There's not a true direct tie-in. There's an estimation, and that estimation right now would be if we get into the nighttime here in the United States and this storm continues to progress as a G4 as anticipated, then we're talking about the aurora being much further south of those northern tier states. It's tough to say anymore because today's technology with digital imagery, people are seeing and photographing the red aurora way high up in the atmosphere from distances much further southward than we would normally think the aurora could be visible. So if we get to that level, this could easily be seen down through the central eastern states into the lower Midwest and into even perhaps Northern California. And that's just probably the lowest, the further south we know it could go to at that level. It can certainly be further south than that. Will this be a global phenomena or seen across the United States, such as the May storm? It's tough to say until we still get a good read on it. And we would really need to reach those G5 levels for that to happen again. And we do have a chance for that. Rob, do you have anything to add to the aurora?
Yeah, no, I think Sean covered most of it pretty well. As he mentioned, people can pick it up now with their cameras, given the types of sensors that most cell phone cameras have these days. So there is a chance, even if you're not seeing it with the naked eye, to still pick it up. And you can monitor the progression of those things on our website at spaceweather.gov.
Okay, thank you guys. Next question is from Marcia Dunn. She says, so in comparison to the storm that happened in May, which was the biggest in 2 decades, she says, what's your best guess on whether this one has the potential to surpass that one?
Hi, Marcia, thanks for that question. Right now, we're leaning towards not surpassing that one. And the difference is the one in May, we had a series of coronal mass ejections, one of them faster than the other, and it kind of swept everything together and just enhanced the effect. This time we have one coronal mass ejection at, mind you, a much faster speed than those from early May. But in that case, we're thinking this could be maybe a shorter duration event than, covering 36 hours, but we never know for sure how long we'll be in these CME clouds as they pass over Earth. So our expectation is G4 is a good likelihood if we think the amount of energy is there when it arrives here and it's all favorable, with a chance for G5, but we don't anticipate an event at this point in time as extreme as the one in early May. Did any of you have something to add to that?
No, given everything we've seen, I think that's the best call we can make at this point.
Okay, thank you. And a follow-up from Marcia, again from the AP. How unusual is it to have 2 storms of this magnitude less than half a year apart in time?
Yeah, thanks, Marcia. For the G4, it's not unusual. We have a good number of G4s throughout a maximum of a solar cycle. The G5, on the other hand, if we do reach that level again, that is highly unusual because, as it was already pointed out, the G5 back in May was the first time we've had that since the year 2003. That means we went through the previous solar cycle without ever reaching a G5. We've already had one this cycle early in the maximum. We have the potential for yet another one. That is highly unusual. I think that just points to how active this solar cycle has been and how much energy the sun is capable of releasing due to all the magnetic changes and things going on this particular solar cycle. Mike or Rob, anything to include?
If you look back at previous solar cycles, beyond the one we just came out of, cycle 24, you'll see typically a couple of these during a couple of the G5 level events during the solar cycle. So it's not unusual, and the timing and the spacing between them, that's just going to vary based on the types of regions that emerge and things. So there's still a lot of uncertainty about when these things happen, but we're working to better understand that.
Okay. Thank you, guys. Next question from Meredith Garfalo of space.com. Is the new coronagraph from GOES-U being involved in this at all?
Hi, Meredith. Thanks for that. This is Sean here again. Mike, did you want to entertain that question?
So the current data from the new coronagraph is available for use internally here at SWPC. However, it's not publicly available, and that won't be coming out until October 22nd. So more to come with all of that. We'll be doing some media events surrounding that date to help highlight that. But yes, some of that data is available on a very limited use internally here at SWPC.
Right. Thank you, guys. Next question is from David Crew. In terms of aurora visibility, do we have projected times?
David, not really. We're going to have to wait. We're approaching winter, right? We're in the fall, so the nighttime hours have dramatically increased, right? So the aurora that we just had this weekend on Sunday night, that was visible by folks very early in the evening, like just within an hour or two after darkness. If we have a G4 or higher level event, or even a G3 for those favorable areas of the country, having the thing develop within a couple hours of darkness and beginning to see it outside of light polluted skies is very feasible in those locations that it could be geographically seen at. And then it could continue on. The key is that magnetic orientation. It's remarkable how quick the aurora can shut down when the magnetic field is no longer favorable and turns unfavorable, the same as Earth's. It's very quick for the aurora to suddenly diminish, and just as quick for it to redevelop. Rob, anything to add there?
No. Again, there's uncertainty around arrival time enough so that really what you're going to have to be looking for is, okay, when does it get dark in the continental U.S. and then what's still going on? So depending on its arrival time and the state of our magnetic field around Earth, that'll determine really how far south and what you see. But we're not able to give it with a whole lot of precision.
And I'll add one thing just for explanatory purposes on how these CMEs unfold here. When they arrive, it's a shock front that arrives here at Earth first. Think of it like a strong cold front moving across the US, and you suddenly just get a blast of enormous wind, all right? But it may take a while for the extreme cold temperatures to show up. It's a similar thing with these CMEs. We get the shock front arrival, an immediate jump up in speed and strengthening of the magnetic field. But the strongest part of the magnetic field, like the extreme cold temperatures, may not show up for a bit because that's in that magnetic cloud portion as it rolls and passes over Earth. So just if people are monitoring this stuff and they see that we had an arrival, but then things look like they're settling down, we still have the magnetic cloud to pass over Earth. So keep that in mind.
Thank you. So Clara Longo de Freitas asks, she says, I know this is a cyclical event, but are we seeing more severe geomagnetic storms? You kind of talked about this earlier, how this is not unusual, but compared to the previous solar cycle, I guess it is an uptick in activity.
Right, it's definitely a much more active solar cycle than the previous solar cycle. We've had roughly 4 severe to extreme geomagnetic storms already this cycle. I don't recall how many severe ones we had last cycle, but we had no extreme levels, and this potentially could be our second extreme storm, even though we stop our watches at G4, everybody. We don't try to do a G5 watch. So we call it G4 or greater because we do have a potential for a higher than G4. Kind of a low-end chance. I think we're calling it 25% chance to reach a G5 level right now based off our forecast. Anybody else?
Well, I was just going to add, we did a little bit of data digging earlier today, and of course, this is all being sparked by the X flare that we had last night, as was mentioned at the beginning. We've had, as far as we can tell, at least 50 X-class flares this solar cycle. So that's just in the past 5 years since the end of 2019. And that includes the X9 that we had just last week, the biggest of the entire cycle thus far. And we've had 46 X-class flares just this year. So definitely higher level of activity than we saw in the previous cycle by quite a margin.
And that's consistent with approaching solar maximum. So your frequency of these occurrences is going to increase as you peak out. And then as you go down, it slowly decreases until you're in solar minimum and the sun looks like a cue ball and nothing is happening.
I saw a question come in a bit about who was talking. You heard from Mike Betwee first there, and then Rob Steenberg. I'm Sean. I'm the one that's usually starting these questions and then flinging them over, just so you know.
Thank you, guys. Next question from Jaden Wen. Is there any data or records on NOAA's website of geomagnetic storms from previous years?
Jaden, thanks for that. Rob, that may be one you can answer.
Yes, there are records available that you can find on the National Centers for Environmental Information, which is also a branch of NOAA. So it's NCEI. And they keep a lot of the records of both solar and geophysical data there. So you will find records there as well. If you visit their website, ncei.noaa.gov, you should be able to find what you're looking for.
Let's see here. I think I have answered one question from at least everybody who has posted a question. So we'll go back to Brandon again. Vigliaro, and I'm sorry, I'm probably messing up your last name, so my apologies, Brandon. I think we already addressed putting it in comparison to the May event. But when you were talking earlier about the predicted maximum numbers, were you talking about the number of solar flares? It's the number of sunspots, right?
I guess I'm not sure what the question.
The solar cycle prediction graphs, yes. The On the left-hand side, that is the predicted number of sunspots.
Okay, predicted number of sunspots. Okay, so is cycle 25 solar max still predicted to be relatively calm compared to, let's say, solar cycle 23 or other previous cycles?
No, not at all. This solar cycle has been adjusted accordingly to have a higher level of activity than we previously had out there. And that's important because there's industries such as the satellite community that has to plan orbital locations for their satellites and fuel loads on these spacecraft years in advance. So they really needed an updated forecast. That's the one of the few groups out there, but probably the most notable one that needs that extended long version of a solar cycle forecast. So that's been modified accordingly, and that does get modified on a monthly basis as we get more data in. So it's kind of an evolving forecast. Did I describe that well enough, Rob?
Yeah, I think so. And you can look at the historical record of sunspots and solar cycles back to the 1700s. You can actually find that data published. And so there were some really big cycles. And I don't think we're going to approach the levels of like 1956, for instance. But it's a decent cycle. And for most of us in this room, we haven't worked as space professionals during solar cycles for very long. So, if you're lucky in a career, you get 2 or 3 of them. And so that's something to consider as well.
I wonder if Brandon was talking about how when the cycle is not predicted to have as high of a peak, it tends to be more protracted, right? So, if you have like a huge uptick, then it usually only lasts for a shorter amount of time.
No, I don't think that's true. These solar cycles, generally, you'll have a fairly quick uptick sometimes. Sometimes they can be more gradual. But then to come down, it takes some time. There's a lot of energy that still has to be released and neutralized. So that's why we think solar peak will probably be sometime this year to early next year, but that doesn't mean the solar maximum is done. We'll still be having increased levels of activity or chances for them throughout 2025 and even into 2026.
And I think there's been some research that has shown you sometimes get your bigger storms as you're coming off of the peak, as you're on the downside. Halloween storms of 2003, I think they were just after the peak.
And even so, September 2017 was the same way.
Exactly. So there does seem to be some evidence that supports that as you're on the downside of the peak, you can get quite a bit of activity as well. So that's just something to keep in mind.
And I'll toss one more thing in here in terms of the profile of the cycle itself. One of the other things we've seen are separate maxima in the northern and southern hemisphere. So you can have a solar cycle that ends up with 2 humps instead of 1. So that's another thing to look out for. And I'm not in a position to say whether or not we're going to see that with this, but it is something to keep in mind.
And another thing of note, these sunspot groups, one of the reasons we think, a theory behind of why some of these storms can happen as we're coming down from maximum is these sunspots migrate throughout a cycle. So if my head is the sun, when a solar cycle begins and sunspots start to form, they tend to be at the higher latitudes in the sun. But then as the solar cycle progresses, some of these strongest sunspot groups tend to show up more and more often near the equator, the center of the sun. We're not there yet. These regions still have a good 10 degrees or so to migrate closer to the equator. So we still have some time. We're pretty confident that we're going to continue to see chances for activity like this. And that may be a reason why they're more and what that's important is they're more in a direct line for an Earth-directed component. They're not down low in the south where they may miss us to the south. 93 million miles is a lot of progression time for these CMEs, but they can still miss Earth, even if they're at the center of the sun, but they're at those higher or lower latitudes. Closer to the equator, it's a more direct shot.
Just like we saw last night with the X-class split, it's right on the center of the disk.
Yep.
It's really interesting, guys. Thank you. We'll go back to David Crew from petapixel.com. He's basically asking for timing projections of the aurora for astronomy photographers.
Hey, David, you need us to be ready to roll, monitor our webpage, that real-time solar wind in particular. be cognizant and maybe subscribe to the actual alerts so you know when activity is taking place, and then you can reference the webpage and the real-time solar wind. Remember, what you're going to be looking for is the enhanced magnetic field, which we expect to have, but what's that orientation? If it's staying northward, I don't know what your location is, but if it's staying northward, it's not as likely to progress further southward. But if it goes the opposite Earth, southward as we call it, that's when things will rapidly spin up and the aurora is most likely.
Did we mention, or did you already mention the aurora dashboard on our website?
No, I haven't. You want to go ahead, Mike?
Go ahead, Brian.
So as Sean has done a great deal of explaining, right, there's a great uncertainty in the timing about the intensity of these. The comparison I like to draw is obviously the hurricanes are in the news these days, right? As a hurricane develops, we have nearly constant satellite imagery. Additionally, NOAA flies aircraft into and above the hurricanes for real-time data. Unfortunately, we just don't have an analog for that, right? We have a snapshot in time, an event occurring on the sun. We are able to make rough estimates of speed, trajectory, when and if it will impact Earth. And then it's a waiting game, really just wait for the CME to hit the L1 point for us to really ground truth both our forecast for timing. So again, that could be plus or minus a couple hours, plus or minus 12 hours. And then also from that, we can then update our warnings to indicate what we think the actual intensity will be. So I want to just emphasize the uncertainty. Sean's mentioned a few tools for people who want to chase the aurora. Of course, you could take a look at the real-time solar wind, where you're looking at measurements actually at the L1 point. The more negative the magnetic field is, the better it's going to be for aurora. We have a number of key forecast websites. You can see in real time what the response here on Earth is. For more amateur photographer, on our website, we have a dashboard called the Aurora Dashboard. There's a few tools on there. The most important one is there's a section that says, where will the aurora be in the next few minutes? That tool uses a model called ovation and takes real-time information coming in from the L1 satellites to predict the probabilities of viewing the aurora in the next 15 to 30 minutes. That's probably going to be the most accurate and easy to communicate representation of where people want to go. So before you grab your camera and grab in the car and try to drive someplace dark, of course, follow us on social media. We're going to be posting on Facebook and X regularly as the events occur. We'll be pushing web updates to our website as well. But the Aurora dashboard, and particularly that real-time model, the one at the bottom part of the page, is going to be really important for playing that to see how those probabilities change overnight, or through the day, I should say.
And I posted the Aurora dashboard link in the Q&A next to the question that Lizzie Acker asked about if the aurora is more commonly visible in Oregon. So all of our webinar attendees can find that link there. We have a couple questions from people who have not yet asked questions, and one of them is from Kasha Patel from the Washington Post. So what concerns do we have for technology issues during the recovery from Milton? And I'll remind everyone that we're still recovering from Helene as well. For instance, if it holds a G4, so basically if the forecast verifies, how will the storm affect navigation systems and internet satellites like Starlink?
Yeah, Kasha, that, we don't know for sure because let's assume it's a G4 and maybe even we hit a G5 level with this storm. That's why we've reached out already. We already have personnel here reaching out to the satellite community. So they have a big heads up on this event. We've already been talking and engaged with FEMA because of the hurricane efforts. We started that discussion already previously. The North American Power Grid we've already talked to this morning, as I mentioned, and that was because of our concern of a stressed out grid already. Let alone if it's a G5, G3 or higher, we're already talking to the power grid, everybody, just so you understand. So when we start thinking of our confidence level is high enough to issue a G4 watch, we now engage with them early, and that's why we did that this morning. But we don't know the status of their electrical systems and transformers and how many voltage lines are down, which could lead possibly to a more stressed out grid if we just don't know. That would be for them to answer. Communication efforts, anything using certain wavelengths or bands, or radio bands, whether it's HF, SATCOM, line of sight systems. Some of these won't be influenced by that storm, some others will. GPS accuracy certainly could be impacted by that storm, as we realized back with the G5 in early May. That includes precision GPSs. I guess we just don't know for sure what all the emergency manager, responders, and search and rescue folks, what they're using out there. There's just too much. for us to know, but that's why we're talking to them well in advance and briefing and advertising the storm, and then at their disposal to take, and we've talked to state watch centers already this morning, emergency watch centers, because we know they have assets deployed for the Helene relief efforts already going on, but alone Milton now showing up. So a lot going on behind the scenes that we're involved with here at the Space Weather Prediction Center, but we just don't know all the implications. So we're doing a little more advertising than usual. Anybody like to add something there?
We did have G3 level storming on Monday night, so just a few days ago. And of course, folks were well underway with the Helene recovery operations all through the Carolinas and down into Florida. And of course, what we're predicting here is more significant than G3. But the good news is that as far as we know, and we don't have all of the information, of course, but as far as we know, there were no significant impacts to communications from the G3 event on Monday night when it comes to hurricane response. Again, we don't have all the information. It's better to talk to the grid operators directly. And we certainly could see impacts if we get a higher level storm, which we're forecasting.
And one thing I'll note is because we've worked closely across government and with industry and academia to raise awareness about space weather, they've been able to add tools to their toolbox to mitigate the impacts. And that's one of the important things, because they know space weather will happen. So having a variety of resources they can draw upon to mitigate those effects is really the key. And that extends across all the different industries.
All right, thanks, guys. We have another question from someone we haven't heard from yet, Beth Dalby. And she asked, does climate change and other factors on Earth intensify the solar cycle? So I think this would be a good opportunity to talk about how there is a slight influence from the factors of on the sun, but it's dwarfed in comparison to what's happening here on Earth, right?
Yeah, I think that's a great characterization. So we know that the sun obviously is our nearest star and has an impact, but the impact in terms of climate when compared to the other drivers of climate it's orders of magnitude less. So we keep an eye on, and the interesting thing is too, the space weather that we see on Earth, for instance, the hurricane that we're currently watching in the Gulf, that can produce waves that actually show up in upper levels of our atmosphere, in the ionosphere. So that can cause interesting phenomena as well. So, it's a linked system, but yeah, there's orders of magnitude difference in impacts.
Thank you, Rob. Next question is from Isam Ahmed. And again, sorry if I mispronounced your name, Isam. What were the worst impacts of the May event? The auroras were spectacular to see for those of you who did not have cloud cover, which I did. But the actual impact seemed limited. Is that fair? I think it was unfair that I didn't get to see it. But he says the actual impact seemed limited. And if so, does that give you confidence for this event? And Isam is from the AFP, which I think is the France press.
Yeah. Isam, thanks for that. We did have a lot of effects from that storm. I'm going to differentiate between effects and impacts here. So effects meaning people are seeing it, they're experiencing issues, they're working the problem. And impact, I'm going to utilize more. It was a more difficult thing to mitigate, and perhaps there was some kind of problem with the system. So for the power grid, we're still investigating that. We've been in meetings with the Department of Energy here in this country and with the North American Power Grid, abbreviated the NERC, if you will. And those discussions are still ongoing, but we do know that they had some high voltage high voltage capacitors trip, things that are carrying over 115,000 volts. What that means is they were experiencing issues. There were other things that were going on within their systems, other devices tripping. When I say tripping, meaning they faulted. And they either dropped out temporarily and had to bring it back up, or they had nothing going through it at the time. These were all results of that geomagnetic storm. The good news is, because of the advance notice they had, because of this work that's been done over the last 20 years with these industries, is they have plans in place. They were able to get transformers that aren't up and running or carrying a full load ready to carry a full load if necessary. They needed time to do that. And then in some cases, it sounds like they may have tested that or done that to help prevent overheating of transformers. And I'm just talking for this country alone here. So the power grid was affected, but just not majorly impacted. We're still looking into the chances of some small level blackouts that may have occurred that were potentially related to that storm, but we don't know that for sure yet. But that's just the extent of that. GPS users, precision GPS users were impacted, especially farmers across the Midwest and Great Plains of this country, because what was supposed to be active in centimeters was off by 10, 12 or more feet. They were unusable, and that cost them a lot of money in their industry and in their work. Satellite operators, over 5,000 or around 5,000 satellites were being corrected to maintain their proper orbital level out there in low Earth orbits, because the storm inflates the ionosphere, one of the outer atmospheres of our globe here, and that causes these satellites to experience and go through a more dense atmosphere. And what that does is it slows them down. Think of your hand going through water and trying to move your hand through thick jello. It's something like that. It slows the spacecraft down and they can deorbit in the atmosphere. Space launch, any space launch that was going on was well aware of the situation and monitoring to see if they needed to postpone launches. Emergency management and response officials, they were well notified of that event. Communication executives, the big wigs across the country that we all rely upon, they were notified and having their briefs. Cyber command, cyber securities were getting briefs, not just because they were necessarily going to experience an effect, but they needed to know what was causing any issues that are showing up. That's huge and pays dividends just to know that alone. Are we under cyber attack? Is it a maintenance issue, or is it space weather? This is important to know and differentiate. So these are things that were happening with the storm in May that we're aware of. There were some other global effects that we know of as well, but I'll just speak for what we know here in the United States officially at this point. Anybody, Brent or Mike?
Well, I think it just reiterates what Rob mentioned earlier, that especially since the Halloween storms of 2003, we've taken a lot of precautionary measures. The industry has taken a lot of precautionary measures, and they've been able to mitigate and take appropriate action to plan for these storms. And I think that's a big part of why we got through the May event without any major serious consequences for those, day-to-day living and carrying out our day-to-day activities.
Yeah, think of it this way. We never like to hear in the National Weather Service anybody dying in a tornado. That's why we issue tornado warnings. Unfortunately, we can't protect infrastructure with a tornado warning. It's just too little bit of timing. For space weather, we do have the ability to do a little protection of critical infrastructure that all of us in this world and country rely upon. And that's why we're so pleased to know that there weren't a dramatic amount of impacts, because it was so successfully mitigated. We're happy to advertise that was the most successfully mitigated extreme space weather storm in history. And that's a good thing to be able to say.
It sure is, especially when it's true, and it is. So we have a question from Kenneth Chang. I could make the argument that this is 3 questions, but you take it as you will. What's the worst case scenario? I presume this is definitely not a Carrington event, is it? Is there any potential to rival the 1989 geomagnetic storm?
We do not anticipate to be at a Carrington level event. The Carrington level event was speeding along at what, double the speed of what we're experiencing now. And that doesn't necessarily directly play into the strength of a coronal mass ejection, but it does give us a clue. We do not anticipate anything on that level with this event. The one in May was certainly, we think, would probably be more prolific than what we're going to experience, but we won't know yet until it gets a million miles from Earth. The storm in 1989 was also substantially stronger, although not 3 times as strong, but it was definitely stronger than what we experienced in May. And within 90 seconds, by the way, everyone, of that CME arrival here at Earth, that's what brought down power in 2/3 of the province of Quebec, Canada. And the northeast part of our country ended up suffering some transformer damage, and other areas of the continent as well. But particularly the Northeast really suffered from that event, but not with a catastrophic blackout like they had in Quebec. We don't know yet what this storm will bring us. So I'm not comfortable comparing to the 1989 storm as of yet, but certainly we don't anticipate anything on the level of the Carrington event of 1859. I hope that addresses those questions.
I believe so. Marcia had a follow-up to what Kasha asked, basically. She wants to know if you guys are worried that this storm might stress Florida's power grid and cause further issues there.
Rob?
Well, one thing I'll say is, in terms of the power grid, what Florida has going for it is its latitude. So it's a farther south latitude. So in order for them to be affected to the degree that might cause significant concern, that storm would have to push pretty far south. So it'd have to be a pretty enormous storm. So they've got that going for them. So I think that adds a little bit more to the comfort level when it comes to the power supply. And the other thing is, like Sean mentioned, why we're here is to let them know so that they can prepare. So given the latitude and the preparation, our hope is that there are no consequences from that.
And we also said earlier, we don't know what the situation is with the power grid in those Helene affected areas of the country. We are an interconnected system here in North America, and we don't know what they've done without any storms aside, just the damage and the power problems in those areas of what they're doing. How have they gotten power from one place to another when there's not the normal voltage transmission line running between them because it's torn apart. We don't know what their situation is, but so that's one of our concerns here and why we started discussing with leadership even earlier about the situation and why they are wanting to know. FEMA would like an update on space weather tomorrow, once again, as we've been doing. And this is one of the reasons why. Nobody knows for sure what the status of the grid is in the affected areas or what it could be after Milton. And that's one of the reasons we are high on what we do.
Another question from Clara Longo de Freitas. Do we know why this cycle is more active than the previous cycle?
No, not necessarily. There are predictions that are out there. Some had predictions that anticipate a stronger cycle than the international panel. But the international panel, they do the best they can with the limited information and the science that they have. And it is what it is. But we don't know. Maybe there'll be some theories come up. Maybe we'll learn a lot more from this cycle. But as right now, I don't have a good answer for that. Rob, do you have any more insight by chance?
No, I'm not aware of anything right now that would give us any definitive answer to that. That's one of the many mysteries of the sun that we're still unraveling.
Got it. Well, it's hard to measure something that's 93 million miles away and 50,000 degrees right off the surface or something like that. Like it's a little different than the in situ observations that we take here on Earth. So Meredith Garfalo has another question. So this was an X-class flare measuring about 1.8, right?
Yes.
So why is this triggering a G4 or greater watch instead of seeing it with the higher X-class flares, higher number like we had in the week or two previous?
Part of it is the location of where the flare occurred. Being on center disk, it's got a better orientation directed at Earth. You want to add to that?
Yeah, sure. It's another mystery of the sun is what it actually is. The storms in May, we had two giant sunspot complexes on the sun, one in the northern hemisphere, one in the southern hemisphere. The one in the northern hemisphere was producing a lot of X-level flares, a lot of R3 events, but no CMEs. Don't know why. This one down south started producing flares. It also started producing associated coronal mass ejections. We don't know this region in the northern hemisphere of the sun that was responsible for this CME release. Yeah, a low-level R3 level event, an X1 flare, but it had a very powerful CME depart the sun from it. We don't know why that would be. We don't know the association of when a CME is going to release. We have no way of predicting whether a CME is ever going to occur or not. We don't have that level of science. We can predict the probability of a flare and the intensity level it may get to. We do have that science, but we don't have the science yet to know if a region is more susceptible to producing or throwing out a coronal mass ejection.
I can say there's a lot of work being done on that particular topic, though, so expect some developments in the years to come.
I'll chime in. It goes back
This is Brent Gordon, by the way. Can you,
Thank you, Sean. I think it goes back to the last question as well. A lot of times it comes down to a matter of luck. We see a gigantic solar flare, we have a huge coronal mass ejection, and Earth may not be in its path. So we can have a solar cycle that is very active, and yet very few coronal mass ejections are actually making it to the Earth. The analogy to terrestrial weather is a very active hurricane season out in the middle of the Atlantic, not near the coast. And so it may be the most active hurricane season on record, but if it doesn't hit the coast, then it's not as impactful as you might expect. Similarly, we could have a very quiet solar cycle, but just be in the wrong place every time and get hit every time. And you have to take that into consideration where these storms are actually going out in inner space.
That's a great point. We had a storm in CME that launched in the last solar cycle, in cycle 23, that would have been blistering had it gone past Earth, but it went out into space. Luckily, it was captured by a spacecraft, so we know how strong it was, and we could kind of map that to what it would have done to Earth. So even though it was quiet, relatively speaking, last cycle, the opportunities were there, just as Brent mentioned.
Excellent. We've gotten quite a few questions. Who was that speaking again? Who was that speaking again? And and thank you all attendees for your patience with that. As you know, we put this together in a matter of hours, and so our slideshow it was very well done, but that was something that I did not put together from 2,000 miles away. But thank you, Sean, for putting together that slide deck. So why doesn't everyone just go ahead and introduce yourself with your job title as well? And then if anyone needs any clarification afterward, I'll make sure that the spellings are in there and all that kind of thing.
Sure, I'll start. So I'm Sean Dahl, that's S-H-A-W-N. Last name is D-A-H-L. And I'm a Space Weather Prediction Center Service Coordinator. I led this discussion off, and I've been entertaining most of the questions, or at least starting them off. Mike?
And I'm Mike Betwy, logged into the webinar here. Last name is B-E-T-T-W-Y, and I'm the Operations Chief here at SWPC.
Hey, I'm Rob Steenberg, and that's Rob, R-O-B, and my last name is spelled S-T-E-E-N as in November, B-U-R-G-H, and I am a space scientist at the Space Weather Prediction Center.
Hi, everyone. I'm Brent Gordon. And Erica, you said you were going to get the names right, so we don't need to spell them out. Perfect. I'm the Deputy Director here at the Space Weather Prediction Center.
I'm Lieutenant Brian Brazier. I'm a NOAA Corps officer currently assigned to the Space Weather Prediction Center, where I fulfill the role as the project manager.
Thank you very much, everybody. Got that out of the way. Okay, one more question. I think we've covered everyone's question, maybe not exactly the way that you asked it, but if I missed something, please put your hand up, and I can call on you verbally or type your question again in the Q&A. But I have a question here from Tony Wood of the Philly Inquirer. Roughly what % of your G4 watch forecasts verify?
Rob. That's a great question. Because G4s and G5s are rare events, and it's a matter of having really small statistics. We haven't broken it out yet by the various magnitudes. So the primary verification method that we use right now, or the primary measure, is whether or not we forecast the storm correctly in the first place, like storm, no storm. And when we do storm, no storm, our probability of detection, it sits in the range of, right now it's about 55%. Now, if you break that out in terms of the different drivers of geomagnetic storms, because it's not just CMEs, but for the CMEs, isolated ones like this, it's sitting around 63%. So we're not at the same level as terrestrial weather when it comes to the capability and the probability of detection numbers, but our actual accuracy numbers, which is a different measure, are sitting around the 70s, which isn't so bad.
Cal, this is probably, I think this is only the second G4 or greater watch we could issue in 20 years.
Yeah, and that's a great point, Frank.
Well, so on that, if you wanted to look at our success rate from typically at this level of intensity, this is only the second G4 or greater watch we've issued since
2005. January of 2000.
So almost 20 years. Of course, the last time we did was in May. I'd say that was a hit. In terms of confirming the forecast. So this is only the second time in 20 years that we have actually issued a watch of this magnitude.
And if you're wondering why that probability numbers, the success numbers seem fairly low, 55 or 60 something percent. Remember all the nuances that go on here. We're predicting way in advance the potential for a storm without knowing anything about its structure until it gets a million miles from Earth. So our warnings fare much better than our watches, and that's one of the significant reasons why.
Space is big.
And we don't have that many observations, like Erica was saying earlier. We're blessed in terrestrial weather to have a ton of observations and models.
Yeah,
Not the case
absolutely.
with space weather.
Yeah, to a large extent, this science is nascent, right? So, okay. I apologize that I don't remember which one of our experts answered Marcia's question about Florida being too far south. You said something. It was, that they're kind of lucky in this situation, a function of latitude. Do you remember? Was that you, Rob?
That's me.
Okay, so Marcia, that was Rob Steenberg. And so all the name spellings are now in the answer column, but this webinar will be available hopefully within the next several hours on spaceweather.gov, which is SWPC's official website. So it'll just be a factor of how long it takes for the video to get processed and everything like that. If we are done with our questions for today, it looks like we're pretty much wrapped up, and we're also close to the top of the hour. So it's a good time to wish everyone a wonderful day. And if you have any questions that come up afterward, feel free to contact us. If you don't already have it, the email address where you can get everyone on this call, me included, is swpcmedia@noaa.gov. So that's swpc.media@noaa.gov. That's probably the best one to use because whoever is on duty, anyone who's available to answer a media request will see that and they can help fulfill it. So without further ado, thank you all for attending today. And thank you again to our experts at the Space Weather Prediction Center for all you do today and every day. And have a great rest of your day.